Welcome back to Stationeers, and I thought it was high time we did a bit of tutorials on Boolean logic. And if you don't know what Boolean logic is, or if that sounds boring, don't worry, it's not too boring at all. I'll be using examples to show you exactly how you might use this, so it's not some kind of dry lecture. So, what is Boolean logic? Well, if you want one or more inputs, and we're going to use Booleans or zeros and ones, just binary, and we're going to test one or more things. For example, let's take the first example here. So let's say we had two pipes, okay? And we were going to input them into a mixer. If we wanted to say, well, I'm not going to let it mix them, and I'm not going to output that mix anywhere else, unless both of these pipes have a minimum level of pressure. Okay, it seems like a reasonable thing to do, but you're asking for a result of both of these. So we could put a pipe analyzer on both of them, and we could read in that value and then test it. So we could do a logic math and say, is the pressure greater than 10,000 kPa? No, that's a bad example for pipes. That would be bad. Is it greater than 5,000 kPa? And if it is, and if this one's greater than 5,000 kPa, then we want to activate something, like maybe the mixer itself, or maybe a pressure regulator or something else, but we're testing two things at once here. So this is our first example. When we're doing that, a good use is an AND gate. And what basically, and this is how I've set this up. So I've got two inputs here. These are fake inputs, just so I can hit this switch, and you can see that I've turned one on, and hit this switch and turn the other one on. And then there is this LED down at the other end. Okay, so we're going to use this writer to activate this LED. So, whatever your test is, these are just fake inputs for it. Rather than setting the entire test up and then showing only one gate, thought we'd get through these fairly quickly, and hopefully we can get quite a lot of information done, in this one video, or at least as many of the logic gates that we can. So what are we interested in here? So if we're trying to test if this is true, and if this is true, i.e. the pressures are both above a certain amount. For example, if I click both of these, that's equivalent to that test, then the output should light up. Or in your example case, you'd turn on a gas mixer, or you'd turn on a volume pump, or whatever you actually wanted to actually do there is fine. So how do we do that? Well, we've got a bunch of different modules we can use. I've put some on the ground. There we are. So as you've seen before, we can use math modules, or you can use unaries, min-max, select, and compares. Okay, so you may be, let's just rotate that for a second, just so it's there. And let me just pop that at math, and maybe a compare. Yeah, we're not going to need the min-max in this one, or at least I don't think we are. So the select unit, as you've seen before, you're examining something, unfortunately only one something. And then if it's false, you go one way. And if it's true, you go another way, and you supply these values by something else, to the left and to the right, however you wire it. And then out of the bottom output, or rather anything that looks at this unit, it will see either this or this, depending how you set things up. The maths is just going to test something. So, this is what you'd use to test your pipes. Is something less than a value of like 5,000 or 500,000 or whatever you actually wanted to put in there. And then finally, we have the compare unit. So we have is something equals something else. So what can we do with this? Our first example, the easiest way to build this is to, let me just pull these off the wall again. Okay, we can do a maths, I think, oh no, hang on, compare. Actually, good point. No, I was right. We did actually need both a math and a compare. So what we're going to actually do with this is take the math unit, and we're going to say input 2 and input 1. Doesn't matter which way around you put them, and we're just going to add them together. Okay, so if this is 1, i.e. it's on, and this is 1, i.e. it's on as well, and this is what our tests will output when we put some pipe analyzers and a couple of math units over here, in the actual scenario, then the output should be on as well. But if I turn 1 off, then the output should be off. Obviously, it's not doing anything at the moment. So we're going to add them both together, and we're just going to compare them to a value. All right, so we're just going to say logic math, which is this output, are you equal logic memory? And that's this output. Okay, so if we've got two inputs, the only result that we can use that we want for an AND is when both are on. And that means it has to equal 2. So we can just write equals logic memory, and we just increase this to 2. There we go. So if we switch one off, you'll see that goes off. If we switch them both off, that's still off. This one on, doesn't matter. Only will work when 2 are on. All right. Okay, now for the OR gate, which is similar, but we're testing something else. So we're still going to add them together and evaluate something. But in the case of an OR, the kind of real way you'd use this is if either of these are on, or if both are on, then the output should be on. But if both are off, the output should be off. So I guess what you could do this as some kind of warning system. So, you know, if any of your inputs are actually outputting a 1, i.e., for example, let's say you had again that those analyzers, and you had a math saying, is this greater than 9,000? I need feel a meme coming on. No, I'm not going to do it. Is this greater than 8,000? 8,000. Let's use that. Okay. Is it greater than 8,000 on any of your actual pipes? If it is, turn this light on, or even better, there is actually a flashing light that you can build. So turn the flashing light on to say, hey, we're getting close to the limit on our pipes. We need to do something about it before you actually do something as serious as like open a valve to space and get rid of it all. So an OR gate is very, very useful for that. So what can we do? Well, again, we're going to add them, but this time we're going to say, is it greater than 0? Okay, so anything greater than 0, we're going to have to change this. Anything greater than 0 will be fine, because if this is on, we're going to get 1. And if this is on, we're also going to get 1. And of course, if both of them are on, hey, it's still evaluating to greater than 0. So away we go. We have a way to check lots and lots of tests, and we can just keep stacking these, to be honest. All you have to do is then you'll have to compile them together. So if you have 3 inputs, you'll need another math unit. And you're going to want to, put it here, and then you're going to have another math unit where you're going to add those two together, and then again compare them to, anything greater than 1 still for OR. For AND, you'll have to do them, equals 3 exactly, or equals 4 exactly, or however many inputs you've added together using the maths units. Hopefully that's straightforward. Okay, so we can build a NAND gate too, and NAND is related to AND, and probably the best use case I can think of this is, our battery charging circuit. We've got a battery over there, it's in the dark, so I'm not going to go over there, but we've got a battery charging circuit over there. If we had multiple batteries, sorry, not over there, it's downstairs, isn't it? That's just multiple batteries. So if downstairs we had a solid generator charging at multiple batteries to have a big battery bank, and we wanted to say, when the batteries are full, or close to full, all of them, then we're going to turn the generator off. But otherwise, it should be on. That's when we want a NAND gate. Okay, so what we can do is say, let's put this together. So yeah, when all the inputs are on like this, that light should be off. Otherwise, any other state, i.e. let's say these are charged full states. Any other state, let's say one of the battery isn't full yet, or its ratio isn't greater than 0.9, or whatever you want to use to define full, then, it's off. But as soon as that happens, that light should be on, i.e. the generator should be on in this particular use case. So we can take this and say, instead, this addition of these two should be less than 2. I think that should work. Less than 2. Okay, so that should be off, but for anything else, there we go. So that's on. That's on. And then if they're both off, yeah, it's still on. Okay. So only when both of your batteries are full will it turn off your generator. Simple? Hopefully. Okay. And finally, for those initial set of 4, we've got the NOR gate. Okay. So NOR is only when we're interested in everything being false. So only when both of these are off does this come on. And that's working at the moment, but it won't deal with one off and one on like that. In a NOR state, only when they're both off will that thing light up. And so let's just change that. What we're going to do is logic math, and we're going to change it to equals and then 0. Okay, so only if they added together equals 0 will that light up. So you can see if I turn on any light, yeah, it won't care. The only state is 0. So again, you could use that for warning systems or anything when, if it's all false, i.e. if your warnings aren't on, then everything will be green. You could change that to a green color. But as soon as any one of your inputs come on, then, well, in fact, wait a second. Is that, oh, that's correct, yeah. Yeah, as soon as any of your warning lights come on, then your green light will go off. Things are going wrong. So yeah, it's just another way of rigging the same thing that you got for the OR gate. It's just the opposite test, if you like. Okay, so for the next one, it's superficially actually harder to think of an example, but there is a good one out there. Let's say we have 2 gas mixers, okay? And this is quite useful, or will be quite useful when I build mine, when I get enough gold, that is. Let's say we have 2 gas mixers, and one uses nitrogen and oxygen, and the other one uses hydrogen and oxygen, and it's oxygen to both of them, okay? Now, I may not want to supply oxygen to both. I may just want to say, look, I'll waste oxygen if if these tests aren't connected to each other in some way. Remember, we have the and ors and the other sort of gates that we can create for like just a pair of 2. But if I don't want to have oxygen be wasted by going to both of them, I want to select only one, then we can look at the XOR gate or the exclusive OR gate. The way that works is if both are on or both are off, then that light's going to go off or the test is going to go off. It's false, i.e. only one place at a time. So either this one can be on or this one can be on, but not both and not neither. i.e. if I want to select a place for oxygen to go, I can send it to this one, or I can send it to this one, but not both and not not neither. It wouldn't make sense. And then of course you'd have another button further along to say, hey, okay, so push a button and out goes your oxygen and out goes your other gases to these mixing units. If you wanted to mix on demand like that. All right, so to set that up, it's really, really easy. Again, we're just going to say logic math equals and then exactly 1. Okay, so now that is false. That's also false, but any of them being on, okay, that's true. So that's the exclusive OR gate. Okay, next to last one, promise. We're nearly through them, is the exclusive NOR gate, or Xnor. All right, so this one is sort of the, if you like, the opposite of the one we've just done. And this is only interested in if both inputs are false or both inputs are true. I can't quite think of an example here. I mean, I'll open this one to the commenters. If you want to watch this and you want to give me an example in-game of what you might use an Xnor gate for, or XNOR, let me know. I can think maybe you can do something with balancing, for example, with furnaces, that you're only interested in both furnaces are at low pressure or both furnaces are at high pressure. You want to balance them, so you don't want one at high pressure and one at low pressure, etc. Maybe something along those lines, but I don't think there's quite as much use as the others, certainly. But it should be straightforward. What we want on this one is not hard. We just change this to not equals and then 1. Okay, so if both are off, we get a positive, and if both are on, we get a positive. But if either one of them is on or off, etc., so you've only got one input, then it's not going to work. So yeah, they both have to be equal. And to be honest, you can compact this even more. This doesn't need the compare unit. I'm just leaving it in here. This one equals, so this, if we just actually remove this math unit and just say is input 1 equal input 2, then that's Xnor, basically. So I've mentioned that in a couple of other videos previously. Now for the last one, and the kind of fun one, or at least it sounds simple, but it may not be something that that we necessarily know how to do easily. So we need to go back to Nand for a minute, and I should have perhaps mentioned it when we did Nand, but it's worthwhile mentioning it now. So Nand is only interested when things are less than 2, if you remember. Hopefully you do, but if not. So less than 2. Is that right? Okay, so if both are off, yeah, it works. If one's on, it works. If another is on, it works, but not if both. Okay, so that's the NAND gate. But we can then use that to create a NOT gate, not a NOR gate, a NOT gate, so reverse the input. In order to do that one, that's actually quite simple. You just attach the inputs to, basically both inputs to the same thing. Sorry, had to cough. Didn't want to do that on camera. So if we set this one input 1, let's set you to, can we set you both to input 1? That's what we actually want here. So input 1 is this one. So if we flip this now, the other one should go off, and flip this back again, the other one should go on. So we're reversing things, and we're basically saying take input 1 and input 1 and add it together. Okay, and this is 2. So is input 1 added together? So 0 and 0 is 0. Is that less than 2? Then yes. But if they're added together, right, this is on, 1 plus 1 equals 2. So it's less than 2, which is this other comparison. And therefore it goes off. So yeah, we can create a NOT gate as well, which helps us reverse things if you need to do that kind of stuff easily. Okay? And just to wrap this up, to give you an idea of, you don't have to just combine ands with ands and ors with ors and etc. If you have more and more input switches, you can also combine these to get really nice systems, particularly for multiplayer. So if you're playing a multiplayer server, and let's say you want a master shutoff switch, just to give you an example, let's say you had some canister refill systems around the base, and you have people, they put the canisters in. If they want refills of air or whatever you're actually supplying to that canister, they can push a switch and then get that refilled, so that the whole thing isn't passive. You're actually forcing the air or the gas through to whichever. You can actually turn on an input. So if we turn on an input here, you notice that it goes on over there, and this one too. That also will send it on. And if both ask for that, then that's fine too. Okay, so that's an OR gate. We've covered that already. If either one is on, then the output's on. And if both are on, the output's still on. Okay, but if we had another switch in place and then try and select one, now what's happening? Now, doesn't matter who's actually asking for things, that's not going to turn on. So in this case, you might have this in your control room or in the gas room or wherever, just to make sure that your gases weren't being supplied out to people while you're actually working on the infrastructure or something along those lines. You're rearranging. Again, same thing with electrics. If you wanted to shut electrics off with a master switch and then had requesters for electrics in particular parts of your base, you could. And to do this, it's quite simple. So we're going to take the OR gate. So this is or math as we did before. So input 1 and input 2, we're going to add them, and then we're going to compare the that or math, and we're going to say, is it greater than the first memory? And the first memory is 0. So if it's 1 or 2, then yeah, it passes. But then going to take this compare unit, we're going to feed it into another math unit. And we're going to say, hey, take the logic compare, now combine it with a master switch and add them together. So the maximum it could be is 2 from this one, but it'll get converted to 1 here. So this can only ever be 0, 1, or 2. And of course, that is the same kind of input that we normally get. So we have another compare unit that says, is this going to be greater than second memory? And second memory is set to 1. So only if both this is true and the result of our OR gate is true, which is anyone's requesting stuff, will this output turn on. There we go. Takes a second to delay, but we can chain things like that and get quite complicated behaviors just by combining logic gates. So I know this has been an electronics heavy episode. I'm going to try not to do that too often, but just because I got some questions about electronics and various bits and pieces, I thought best to cover it all at once, just so that when I actually do build, you know, a gas system or something, you know what I'm talking about when I'm talking about logic gates. Okay, I may not be good enough with electronics to recognize that Schmidt trigger that we had last episode, but I do know enough about the logic gates to actually get them to work. And definitely the easiest way to build them is just by comparing to values, i.e. greater than, equals, not equals, and less than, to specific values, and then use the inputs as zeros and ones to actually calculate that out. Okay, hopefully you enjoyed this episode. I know it's been a lot of information, but hopefully the examples I've given are good enough for you to actually use them in your own designs. Whether or not you do, of course, it's up to you. But if you know of any other examples using logic gates, or any other examples that you think might be able to be done, put them in the comments below. I'm sure other people will be happy to comment on them as well, and let you know how let you know how to optimize your design. Yeah. Okay, thanks a lot for watching, guys. Feel free to give it a thumbs up if you've enjoyed it, and of course subscribe and share with other people as you normally have been doing. Thanks a lot for watching, and we'll see you next time.